All right, so today we will be talking about the content of arterial oxygen, which we've discussed in class, and how I want to elaborate on that is let you know the content of arterial oxygen is the amount of oxygen in 100 milliliters of blood. Why is that important? That's important because our whole job in oxygen transport is to get oxygen from the air to our fingers, our toes, our kidneys, our liver. And knowing how much oxygen is in the blood will let us know whether or not we're meeting the patient's demand. Because if we don't have enough delivery to meet the demand, we'll have a deficit. So, content of arterial oxygen, CaO2, is the amount of oxygen in milliliters in 100 milliliters of blood. So if I drew that out, it would be 100 milliliters. And how much oxygen is in there? I want to know. So in order to figure that out, we need to look at how much hemoglobin we have, and every gram percent of hemoglobin can carry 1.34 milliliters of oxygen. So if I know how much hemoglobin I have, and I know how much that the hemoglobin can carry, and then I times that by my oxygen saturation, I can find out how much is carried on the hemoglobin molecule. Normally, our O2 saturation is about 97%. Our hemoglobin is about 15 grams percent, and we have 1.34 milliliters of oxygen carrying capability on each hemoglobin molecule. So if we figure that out, and then we add the amount dissolved in plasma, which is our PaO2 times 0.003. That's a constant. That will give us a little bit more oxygen that's dissolved in plasma. It really doesn't change our number too much. This number, if we figure it out for a regular adult male with a hemoglobin of 15%, is about 20 volumes percent. 20 volumes percent. Then what that means is in 100 milliliters of oxygen, we have 20 milliliters of oxygen. In 100 milliliters of blood, we have 20 milliliters of oxygen. And for a normal person, they have about 5 liters of blood that is circulating round and round in their body. So if I figure out how much is in 100 milliliters, and I have, in 1 liter, I have 10 of these 100 milliliter segments or sections, I will come up with in 1 liter of blood, I will have 200 milliliters of oxygen, because it's 10 times 20. 20 in 100, and I have 10 of those in 1 liter. So if I have 200 of these, 200 milliliters of oxygen in 1 liter, and then I have 5 liters, each having 200 in each of these liters, and I have 5 of these. That means in a minute's time, I can deliver 1,000 milliliters of oxygen, because O2 delivery is made up of my content of arterial oxygen, which we just figured out is 20 volumes percent, times 10, which turns it from milliliters to liters, times my cardiac output. And in our case, in most cases, that cardiac output is about 5 liters. 5 liters is a normal cardiac output, or QT. It's called either one. It's normally about 5 liters of blood. So if in every liter I have 200 milliliters of oxygen, in a total oxygen transfer, O2 delivery, DO2, I can move 1,000 milliliters of oxygen in 1 minute. 1,000 milliliters of oxygen in 1 minute. And that is our lesson for content of arterial oxygen. It's 100. It's the amount of oxygen in 100 milliliters of blood. How we figured that out? We got the hemoglobin times the 1.34 times our saturation percentage plus the amount dissolved in plasma. That comes out, a normal is about 20 volumes percent. If I want to find out what the CaO2, it's normally about 20 volumes percent. 20 volumes percent is a normal CaO2. Then if I want to find out how much is delivered over a minute's time, our DO2, I take my 20 volumes percent, that's in 100 milliliters, times it by 10 because that's in 1 liter, and then times that by how many liters I have, which is 5, and that gets me 1,000 milliliters of oxygen.